Welcome viewers, in this video we will see the solved problem based on the cut set schedule. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Cut set schedule solved problem coming under network topology. Now we'll see the problem statement. Find the cut set matrix and the branch voltages current for the network shown below. So this is the network given. Network is nothing but connection of the elements, network elements. Here three resistors are available and one voltage source is available. It is connected together. It's called a network. The question is we need to find the branch voltage and branch current. Here there are three nodes are available. Node is nothing but junction point of the elements. Node A, B and C. At node A, voltage source, this 2 ohm, another 2 ohm connected. At node C, this 1 ohm and these 2 ohms are connected. At node B, this voltage source and 1 ohm is connected. Node is nothing but connection of junction point, connection of the network element, junction point at which network elements are connected. From the network we can draw the oriented graph. The graph is nothing but the network elements are replaced by the straight line, replaced by the line. It's called a graph. The direction also available mean oriented graph. Here this voltage source is replaced, is named as branch 1. These three resistors also replaced by the line and named as 2, 3, 4. This 1 ohm is 2 and these 2 ohms are named as 3 and 4. These directions are given according to our own direction. Directions are not given in the problem. It is randomly the directions are given. So the network, from that we drawn the oriented graph. Oriented graph means network elements are replaced by the line and the direction is available. So from this the number of node equal to n equal to 3, A, B, C. 3 nodes are available. So the number of cut set is n minus 1, 3 minus 1, 2. So for this given network there will be 2 cut sets are available. Now we'll see how to draw the cut set. First we need to draw the tree. Tree is nothing but subgraph of the oriented graph, subgraph having less number of branches. There are n number of trees we can draw. This is one of the tree covering the branch 2 and 4. Node A, B, C, there is a tree, this one type of tree having the branch 2 and 4. 1 and 3 is not covered. Branch 1 and 3 is not covered. So that 1 and 3 will form the cut set, 2 cut set. At node C, all are connected. At node B, not connected. 1 is not connected. At node A, 3 is not connected. So the node B will form one cut set. Node A will form another cut set. So there are 2 cut sets are available. There it is given at node A and node B. Now we'll see the cut set. So the tree in that the branches not covered will form the cut set. This branch 1 is not covered, 3 also not covered. So 3 not covered at node A form one cut set. This is the cut set. At node B, branch 1 not covered, that form another cut set, C1 and C2. Right? So the graph redrawn with the cut set C1 and C2. So the network from that oriented graph, we have drawn the tree. From the tree where the branch is not covered, we can draw the cut set matrix, cut set diagram. From this diagram, we can go for the cut set schedule. We can frame the tabular column, cut set schedule. So this 1, 2, 3, 4 are the branches. V1, V2, V3, V4 are the branch voltages. E1 and E2 are the tree branch voltages. That is this 1 and 3 is the tree branch voltages. E1 and E2 is nothing but tree branch. This is a branch. At C1 the tree branch voltage is E1. At C2 the tree branch voltage is E2. So this tabular column we have the branch voltage V1, V2, V3, V4. Tree branch voltage is E1 and E2. The notation is different. Tree branch means this is tree branch 2 and 4 is a tree branch. Right. Now we can frame the tabular column. Now we'll see the cut set schedule C1. First we'll see the cut set schedule C1. Here 1 and 2 is connected. See the direction, the branch direction of 1 and cut schedule both are opposite, means +1. See the branch direction 2 and cut schedule both are same direction going this side, is -1. 3 and 4 is not connected with the C1, so 0. So at branch 1, cut set C1 direction both are opposite, +1, both are same, -1, not connected, 0. Then cut set schedule C2, 1, 3, 4 are connected, 2 is not connected, so 2 is 0. 1 is connected, see the direction, same direction, -1. 3 and 4 opposite direction, so +1. So accordingly we can frame this cut set schedule. So vertically we have 3 branch voltage E1 and E2 based on the 2 cut set. Vertically we have, horizontally we have branch voltage V1, V2, V3, V4. There are 4 branches. Both are related. At C1, 1 and 2 connected. 3 and 4, 0. 1 is opposite, so +1. 2 is same, -1. At C2, 1, 3, 4 are connected. 2 is not connected, 0. 1 same direction, -1. 3 and 4 opposite direction, +1. So this is the cut set matrix based on this 1, -1, 0, 0, -1, 0, 1, 1. So from this cut set matrix we can go for the voltage equation as well as current equation. How will you find the current equation? See in this, I1 minus I2 equal to 0. I3, I4 are 0, already 0. The second row, minus I1 plus I2 plus I3 equal to 0. By using the Kirchhoff's current law, we can write the equation. I1 minus I2 equal to 0. Minus I1 plus I3 plus I4 equal to 0. We can write the two equations. Similarly, we can write the voltage equation. How will you write the voltage equation? V1. Here +1, -1. E1 is +1, E2 is -1. So we can write E1 minus E2. V1 equal to E1 minus E2. V2, only E1 is available, -1. So V2 equal to minus E1. E2 is 0. V3, only E2 is available, +1. So V3 equal to E2. V4, only E2 is available, 1. This is 0. So V4 equal to E2. Right? So V1 is E1 minus E2. V2 is minus E1. E2 is 0. V3 is plus E2. E1 is 0. V4 is plus E1. So we can write the voltage equation. So from the cut set matrix, we can able to write 4 voltage equations and 2 current equation. Now we'll see this in detail. So what we discussed is available as a equation. But for the row, we can apply KCL. Let I1, I2, I3, I4 be the branch current of the branches 1, 2, 3 and 4 respectively. So by applying KCL to the row 1, we already discussed I1 minus I2 equal to 0. Take this equation number 1. By applying KCL to the row 2, minus I1 plus I3 plus I4 equal to 0. That we already discussed is equation number 2. So we are able to frame the 2 current equation by using the KCL. Similarly, let the branch voltages are V1, V2, V3 and V4 for the branches 1, 2, 3 and 4 respectively. E1, E2 is the tree branch voltage. V1, V2, V4 is branch voltage. So what we discussed from the column, we can able to write V1 equal to E1 minus E2. V2 equal to minus E1. V3 is E2. V4 is E2. So what we discussed in the matrix, we are able to write the 4 voltage equation. It's numbered as equation 3, 4, 5, 6. This current equation 1 and 2. Other equation 3, 4, 5, 6. So by using this 6 equation, we are able to find the branch voltage and branch current. Now we can redraw the network indicating the current direction. So this 30 voltage source available and 3 resistor 1 ohm, 2 ohm and another 2 ohm. The node are A, B and C. Let the current from the voltage source is I1. So the I1 is flowing through 1 ohm resistor. I1 is current is flowing from the voltage source. The current flowing through 1 ohm is I2. Then I2 is splitted I3 and I4. So current flowing through this 2 ohm resistor is I3. This 2 ohm resistor is I4. So there are 4 currents. I1 current flowing from 30 voltage source. I2 current flowing through 1 ohm resistor. I3 current flowing through this 2 ohm resistor. I4 current flowing through this 2 ohm resistor. From that we can write the voltage equation. So V1 equal to minus 30. Because of negative polarity, minus 30. Current is flowing from the flowing in the reverse direction. So this minus 30. V2 is nothing but V2. V equal to I into R. I is nothing but I2. R is 1 ohm. 1 ohm into I2. Then V3. V3 equal to V equal to I into R. I is I3. R value is 2 ohm. 2 into I3. Similarly V4. 2 into I4. So V1 equal to minus 30. V2 equal to I2. V3 equal to 2I3. V4 equal to 2I4. Equation number 7, 8, 9, 10. Already we have 6 equation available. First 2 equation current. Remaining 4 equation voltage. So here we have another 4 more equations are available for the voltage. Now we can compare equation 3, 4, 5, 6 voltage with this 7, 8, 9, 10. Both are same. By comparing that we can able to find the voltage value. So 3, 4, 5, 6, 7, 4 equation, one set of voltage equations available. 7, 8, 9, 10, another 4 set of voltage equation available. So first we will take equation 3. That's nothing but V1 equal to E1 minus E2. But equation 7 we have V1 equal to minus 30. Value is available. So we can replace V1 equal to minus 30. So minus 30 equal to E1 minus E2. Brought that minus 30 that side, so it become plus 30. That is E1 minus E2 plus 30 equal to 0. Right? Equation 3, V1 equal to E1 minus E2. At equation 7 we have the V1 value is available, minus 30, that is substituted, and we framed the one more equation 11. Then equation 4 is V2 equal to minus E1. But from equation 8, V2 equal to I2. So both are same. So I2 equal to minus E1. Equation number 12. Equation 5, V3 equal to E2. But from equation 9, V3 equal to 2I3. So both are same. This right side is same. So the left side also same. 2I3 equal to E2. Equation number 13. Equation 6 is V4 equal to E2. But from the equation 10, V4 equal to 2I4. So both are same. 2I4 equal to E2 is equation number 14. Now we have the equation 11, 12, 13 and 14 available. But from equation 1, I1 minus I2 equal to 0. So that brought this I to that side, so it become plus I2. So I1 equal to I2. We got one more relation, I1 equal to I2. Equation number 15. Now we'll go for the further simplification. Now we'll take the equation 11. What we framed equation 11 is E1 minus E2 equal to minus 30. From equation 2, minus I1 plus I3 plus I4 equal to 0. Now all these values are available. From equation 12, 13, 14, these values are available. I1 equal to I2. Just now we discussed I1 equal to I2. So I1 is replaced by I2. Both are negative. I3 is E2 by 2. I4 is E2 by 2. So that is from the equation 12, 13, 14. So I2 can also replace as minus E1 plus E2 by 2 plus E2 by 2 equal to 0. So negative it become positive E1. So E2 by 2, E2 by 2, 1 by 2 plus 1 by 2 is 1. So it become E2. So E1 plus E2 equal to 0. We have 17, equation number 17. But equation 16 what we have, E1 minus E2 equal to minus 30. This is equation 16. But in equation 17 what we have, E1 plus E2 equal to 0. So we can add both the equation, because by adding this E2 got cancelled. So E1 plus E1, 2E1 equal to this got cancelled, minus 30. So E1 equal to minus 30 divided by 2. So the E1 equal to minus 15. Now we got the one value, E1. There is nothing but branch tree voltage. E1, E2 is the branch tree voltage. Now from equation 17, E1 plus E2 equal to 0. E1 we calculated, E1 is minus 15 plus E2 equal to 0. Brought this minus 15 that side, become plus 15. So E2 equal to 15 voltage. So E1 equal to minus 15 voltage, E2 equal to plus 15 voltage. Now we calculated the voltage. Now we'll go for the current value, I1, I2, I3 and I4. Before find the branch voltage, we'll find the branch current, we'll find the branch voltages. That is V1, V2, V3 and V4. E1, E2 already calculated. From that we can easily calculate V1, V2, V3 and V4. V1 equal to, from equation 3, V1 equal to E1 minus E2. So we calculated E1 is minus 15 minus E2 is plus 15. So minus 15 minus 15 minus 30 voltage. V1 equal to minus 30 voltage. From equation 4, V2 equal to minus E1. Minus of E1 is minus 15. Minus of minus 15 become plus 15. V2 equal to 15 voltage. From equation 5, V3 equal to E2. E2 value is 15 voltage. So that V3 equal to 15 voltage. From equation 6, V4 equal to E2. E2 is 15 voltage. So that V4 equal to 15 voltage. Now we got the branch voltage. V1 equal to minus 30 voltage. V2 equal to 15 voltage. V3 equal to 15 voltage. V4 equal to 15 voltage. Now we got the E1, E2 value as well as V1, V2, V3, V4 value. Now we'll go for the branch current. Now we'll find the branch current one by one. So from equation 1, I1 minus I2 equal to 0. So that I1 equal to I2. Brought the I2 that side, so it become plus. I1 equal to I2. But from equation 12, I2 equal to minus E1. From equation 12 it is available. So I2 is replaced by minus E1. So minus of E1 is already minus 15. So minus of minus 15 become 15 amperes. So the branch current I1 is 15 amperes. From equation 12, I2 equal to minus E1. Minus of E1 is already minus 15. So minus of minus 15, 15 amperes. E1 equal to minus 15 voltage. So I1 equal to 15 amperes, I2 also 15 amperes. Now we'll find I3 and I4. From equation 13, 2I3 equal to E2. So I3 equal to E2 by 2. We know that E2 is 15 voltage. So 15 by 2, 7.5 amperes. I3 value is 7.5 amperes. From equation 14, 2I4 equal to E2. So that I4 equal to E2 by 2. That is E2 is 15. 15 by 2, 7.5 amperes. So E2 also 7.5 amperes. So now we calculated I1, I2, I3 and I4. I1 is 15 ampere, I2 is 15 ampere, I3 and I4 is 7.5 ampere respectively. So now we calculated branch voltage as well as the branch current. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.